This is section 8.2, arithmetic sequences and partial sums, objectives. You can go ahead and read them. I'm going to move on to the next slide. Vocabulary key concepts. First one is arithmetic sequence, common difference, sum of a finite arithmetic sequence. You're going to notice that you saw these concepts in Algebra 2. For the most part, should be review. Here's number 1. It says use the table featured of a graphing utility to find the first 10 terms of the sequence. The rule is a sub n is equal to 4 over 5n plus 12. Let me go ahead and give you the answers, and then I'll show you how to use the graphing utility. So first thing you want to do is you want to go to hit the second key, then the stat key, followed by the ops, highlight ops, the operations. Then at this point you want to go down to 5, which is the sequence. Enter that one. And then you want to type in 0.8. 0.8 is the same thing as 4/5. Since you don't have n on the calculator, you have x and beta and some other variables. So that just do x plus 12 and then comma followed by x. 1 comma 10. Where do these numbers come from? The 1 and the 10, because this is the first starting value and this is the last value. Why do we type in this x? Because it's the x value that keeps changing. 1, 2, 3, 4, all the way to 10. Once you do that, press enter, and then you should have this on your screen. 12.8, 13.6, which are the answers that you see here. Let's move on to number 2. It says find the sum of the finite arithmetic sequence. Here you're going to use this formula. You saw this in Algebra 2. Notice that the number of terms that you're adding, that's what the n represents. The a sub 1 is the first term. The a sub 7 or the a sub n, the last term, is 19th. So you plug that into the formula you see here, you simplify, and you get 70. For number 3, similar steps. You can apply the same formula. The n is 100 because you're actually adding 100 terms. Your first value is 1, the last value is 199. Plug this information into the formula, and you end up with 10,000. Number 4, it's just a little bit different. You have to be careful here. N is actually 61. You're going from -10 all the way to 50, and you cannot forget that we have 0 as well. That's where the 61 terms come from. And then the first value is -10, the last value is 50. You plug this information into the formula, and you end up with 1,220. Let's move on to the next slide. It says find the partial sum without a graphing utility. So here we're going to be using that same formula. Notice that this is actually arithmetic. The common difference is 2. You learned this in Algebra 2. Excuse me. So then you have a total of 100 terms you're going to add. The first term is when you plug in the lower limit of 1, you get 2. The last term is 200. When you plug in the upper limit, terms that you learn in Algebra 2, you plug this information into this formula, and you end up with 10,100. Number 6 looks a little bit different. Nothing we can handle. Basically, you're going to do this twice. So let's look at computing this one first. Notice at the end, you're adding you have 50 terms that you need to add. Your lower limit is 51, the upper limit is 100. There's a total of 50 terms. The first term is 51, the last term is 100. You plug this information into the formula, and you get 3,775. Now let's compute this one, the second one. Very similar to number 5 and 6, the first part of 6. This is what you get for the n, the a sub 1 and the a sub 50. Plug this information into the formula. You get the following. And don't forget that we're subtracting these two sums. That's why the answer is 2,500. Number 7. So basically we apply the same idea. Same formula. The first term is 1,000. The last term is 750. You're adding a total of 251 terms. Why 251 terms? And over here, 100 is whatever we have. Here we have 100, and that's the number of terms we're adding. Here we have 250, and we're adding 251. And the reason why we have 251, look at the lower limit. Here's 1, and here's 0. That explains why we have 251. I can clarify this a little bit more if you want me to in class. Talk to me. Substitute into the formula, and this is your answer. Let's move on to the next slide. Now we're going to be using the graphing utility to find the partial sum. And these are the steps that you need to take. You're going to go to second, stat, go to the math key, followed by, you want to go down to the sum, which is number 5. Go back to second, stat, now go to ops, now you want sequence. Then you're going to type in this information, 50 minus 2x, which is basically this. Instead of using n, we're going to have to use x. Comma, comma x, 0, comma 50. Lower limit is 0, the upper limit is 50. This is where these numbers are coming from. And then you press enter, and you should have your answer of 0. Number 9, very similar to number 8, using the calculator. You follow the same steps as number 8. The only thing that you need to punch in is this expression, which is going to look something like this on your screen. And then at this point, you press enter, and you should get your answer, which turns out to be 2,602.5. Let's go to the next slide. This is the number. This is number 10, the last one, and it reads, talking about number of logs. The problem says logs are stacked in a pile as shown in the figure. The row has 15 logs, and the bottom row has 24 logs. How many logs are in the pile? So this is what you're going to do. Notice that your first term is 15, the second term is 16. Where am I getting these numbers? From here, 15, 16, 17, all the way to 24. Now, you're going to notice that this is actually an arithmetic sequence, and the common difference, this is what the D is, you learn this in Algebra 2, is 1. Why is the common difference 1? It's because we keep adding 1. And then at this point, we know we can use this formula. We find out what n is, which is 10 terms that we're adding. The first term is 15, the last term is 24, which corresponds to the number of logs in the first and last row. Plug it into the formula, and this is your final answer. 195 logs are stacked in this pile. And this concludes the video of section 8.2.